Day before yesterday, when I was knitting the first piece of this sweater, I thought I was going to have to beg Arnold Schwarzenegger to come help me knit. Perfectly nice yarn that knits in the middle of the dial on my Brother 260, a machine that I've never had any real trouble with. I just clean it routinely. And you know, they're built like iron. Well, they are built of iron, actually. Anyway, it was static, of course. We were having possibly the windiest, driest day we've had in several years. This is a humid part of the country normally, but that day was not. And it just ground and moaned. It knitted all right, but it was so difficult. Dak agreed with me that it was probably unusually bad static. So he made this ground strap that you're looking at. I will show it to you in other angles and off of the machine. We've got it hooked securely to the clamp that actually holds the machine to its table. This machine has rubber feet on the stand, so of course it's not grounding itself even slightly to the floor. Today, when I came into work, knitting was not as difficult, but it was still tougher than it should be, and I could find nothing wrong with the machine. Here's an elderly and hideous desk that I use as another machine stand, and it sits on a stone hearth that goes all the way to the ground. So we clamped the other end of the ground strap to one of these metal drawers and then gently closed the drawer so it's getting really good contact. And now it's knitting like a dream. There are other static control methods. Some people have success with dryer sheets. I can't even try them because I'm allergic to them and they make me sneeze violently. Plus, they're not likely to handle the amount of static we have had this winter. There are some grounding options that are not positive grounds all the way to the earth, but still do manage to spread out the static charge, and they can help. But this year, this solution has been the only successful one.
All right, here is our ground cable, and you'll notice that it's a hodgepodge of a number of different wires. The red and the black right here are both number 10, but this clamp already had itself attached to a number 8 wire, so that's what we did.
Are you making the point that this isn't fancy electrical work that odds and ends will do? Okay.
Yes. So it doesn't have to be one long continuous piece as long as you have good crimped butt splices and you can actually use a test meter to do the continuity. But let's look at this clamp. I like this guy, and here's why. Look at where he needs to go. He needs to go on one of the stobs of your clamp.
I'm going to zoom in for a minute. That does hug nicely, doesn't it?
It does. And if you want it to go right here, it still has a good bite, you see? If you want it to go right there. So I like this little clamp for that reason. It's got a good spring load.
So where does a person get those?
At a hardware store.
It's a normal thing.
It's a normal clamp. See, most people are used to what's called an alligator style clamp. That's this. And this is a low profile type of clamp.
So you made this to go to my machine that was having such a conniption.
That's right.
And the other end went to the drawer of the desk.
Right. See, because you always have your clamp on the bed, and like I said, there's a good bite right there. There's also a good bite down here on this screw. Okay? So that's what you want is
turn it. Yeah.
Something that will get on there and not tug off in case you trip over the wire, okay? So that's on this end, and here's what we did. We crimped on an eyelet.
Let me zoom in. There we go.
We crimped on an eyelet because this particular style, another nice thing, is it comes with a screw that goes all the way through it to make a good tight bond. So you just crank it down on there. And then, of course, it's got little tabs here that you crimp over your wire. And again, you don't want something that if you catch it with your foot is going to pull apart.
And there's no rule that you have to use odds and ends should you possess a single length of cable.
Right.
You may use it.
A number 10 wire is the best. The larger the number, the smaller the wire. And the 10 is this right here. It's a good heavy-duty 12-strand or 10-strand wire, but it's got some flexibility. You see, that's the important part. Now, let's see what we did here. This, of course, is what went to the desk drawer. And as you can see...
And on rough days, it still goes to the desk drawer.
And you can see it's got a good bit of bite to it. It'll cut circulation off in my finger. So, but it's only got one angle. So the desk drawer is most like the flat of the clamp.
Yeah,
and you see it's got a good bite there. And if you get it over the edge, then it's got a really
depending
good bite.
on what you find to ground to, you would select an appropriate clamp.
Right, now, and you'll notice this one has a good wide grip, so if you had a post somewhere, that would bite to it. But let's look at what we did here, because they tell you to solder this connection. And if you have a soldering iron and you're good with it, that's not a bad idea. I'm going to pull this off just to... I think I will. No, I won't. Yes, I will. Just to get it out of our way so we can see a little better what's going on. So here's what I did, is you have, let me get my little indicator here. You have a crimp section, and you're supposed to feed the wire through it, and then soldering. And this area right here is just like this area that would not quite close around that butt connector, but it will close around the open wire. So since I didn't have my soldering iron with me when I made this, I bared enough of the wire to go through this loop in here and then crimp the bare wire with the squeezables.
And it obviously made an adequate connection because it works like gangbusters.
That's right. And all you do is take your pliers and squeeze it until it won't squeeze anymore.
And you're not really doing electrical work. We're just freeing static electricity.
And this end will show you where the wire went through. It went right in there. And then I closed these two ears over the top of the bare wire to make our connection. It's just like a crimped butt connector. But yeah, this is not high amperage electrical work. It's just to have a flow of electrons from the machine.
To get rid of that darn static.
Right, to a source that's thick enough, heavy enough, bulky enough to accept a flow of electrons.
And conduct them away from us and to the ground.
Right, right.
The deal was with the desk, it's on the hearth. The hearth is in fact grounded.
Yes.
That's an old house feature.
That's right. That hearth, even though it's on the second floor, is built into the chimney structure, and the chimney starts on the ground with a stone structure and then bricks its way up through the house.
In a modern house, you'll have to think of something else. At one time, plumbing pipes were used, right?
That's right. That was the standard back in the 60s, was just run a ground strap. Used to have static buildup from televisions, from radios, and because they were tube types. And so, yeah, that's what they would tell you to do. Just run a strap over to the nearest plumbing pipe, and since the plumbing pipes are in the ground...
But PVC pipe is no use in that regard.
No.
So you'll have to put on your thinking cap if you live in a modern high-rise. Perhaps the maintenance guy will have a clue.
Right. And in this room, we went out the side door to the fence post that was in the ground. Works great.